Hello everyone. The title of this video is Condensing Logarithmic Expressions. So in this video I'm going to be doing examples that are taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 6.5, called Logarithmic Properties, and I'm under the heading Condensing Logarithmic Expressions. In this video, the examples I do will be either an example from the reading or one of the try it problems from the reading or one of the exercises at the end of the section that's related to this particular objective. Alright, now for condensing logarithmic expressions, we're going to be given an expression involving logarithms and asked to write them as a single logarithm using the properties from that we saw in expanding logarithmic expressions in previous videos from this section. These properties here. Remember the product property, the product rule for logarithms, the quotient rule, and the power rule. Now in the last video I did, we expanded. That was going this direction, the way I have them written. Alright, looking at a log of a product, writing it as a sum of logs. Looking at a log of a fraction and writing it as a difference of logs. Looking at the log of a power and pulling that power out to make it a product. That was expanding. This video we're just going backwards. Alright, going in the other direction is condensing. Alright, or writing as a single logarithm. So now when you see a number times a logarithm, put that number inside as a power. And I would suggest using this property first. Put a little star next to it. Alright, we're going to use this property first in condensing. If I see any numbers that are coefficients of a logarithm, I'm going to put those numbers inside as the power. Alright, the power on the input. And then I'm going to go from left to right, taking two terms at a time, and use the product rule or quotient rule as I see them occurring. So if I see the sum of two logarithms, I make the log of a product. If I see the difference of two logarithms, I'm going to make the log of a fraction, the log of a quotient. And I'll keep doing this until we have a single logarithm. Alright, so let's get to it. So the first example here, and all the examples, right, I'm asked to condense the logarithmic expressions, write as a single logarithm. So looking at this first one, there's the coefficients of the logs are 1, 1, and -1. The numbers in front of all the logs are 1, really. So I don't need to use the power rule here. Alright, so then I go from left to right, just taking two terms at a time and applying the appropriate rule. So the first two terms I see going from left to right, I have a sum of two logarithms. So that means I'm going to be applying that product rule. So this becomes a single logarithm, log base 3, of, and then the input of this new log is just the product of these two inputs from the sum, 5 times 8. Alright, which is 40, I know. And then don't forget now we have this, still have this minus the log base 3 of 2. And here I'm seeing the difference of two logarithms. Again, just taking two terms at a time, going left to right. I see the difference of two logarithms. So I'm going to put those together, make a single logarithm using that quotient rule. And I get my final expression here. This would be the log base 3 of, and then the numerator is the first input, right, from the difference, 5 times 8. and then divided by, the denominator is the second input from the difference 2. And of course, if we have just numbers in here, we should simplify this. 5 times 8 is 40, divided by 2 is 20. So the log base 3 of 20 is my final response, is that original expression written as a single logarithm. And then let's check our result. So I'm going to go to a calculator. I'm going to go to that Desmos calculator, desmos.com, free online graphing calculator. And just off to the side here, do some calculations. We had the original expression we were given was the log base 3 of 5 plus the log base 3 of 8, and then minus the log base 3 of 2. Right, you see I'm getting this value here, 2.72683302786. Well, let's see what that, if our final expression is correct, it should have the same value. Right, we said this will be equal to the log base 3 of 20. And look at that. It indeed is the same number. 2.72683302786, blah, 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 right? Oh, great. Means we did well. All right, and I'll leave the checking to you for the rest of these. All right, so in the second example, again, the same thing as the first. All the numbers in front of the logs are either 1 or -1. So I'm not going to apply the power rule here. All right, so I just go left to right and just taking 2 terms at a time, applying the appropriate rule. So here I have a difference of 2 logs, right? So that's going to be the quotient rule. This will be equal to the log base 10, right, of 3/4. Right, 3 divided by 4. Right, and then I'll write the rest of it out. We have plus the log of 5, and then minus the log of 6. And then the next 2 terms, I have a sum of 2 logarithms. So I'm going to be applying that product rule to put them together. So this is equal to the log of, now 3/4 times 5, right? 3/4 times 5 would be 15/4. Right, that's the product of 3/4 and 5. Minus, and then the log of 6 is still there. And then finally I have a difference of 2 logs, so I'm going to be using that quotient rule again. So this is the log of, now I hope you recall that dividing by something is the same thing as multiplying by the reciprocal. So when you have, 15, I could write it this way, 15/4 divided by 6. I mean, this isn't wrong. And then you can multiply the top and bottom by 4 to cancel the 4 up here. But dividing by 6 is the same thing as multiplying by 1/6. Right, this would be the log of 15, 4 times, you just multiply the denominator by 6 basically. Right? When you divide by 6, you're just multiplying the denominator by 6. So this would be 15/24. But of course that reduces, right? These have a common factor of 3. That's 3 times 5, that's 3 times 8. So this is 5/8. The log of 5/8 when you totally simplify it. And there we go. And once again, I'll leave this to you. You can check this on a calculator. Punch this, expression that you started within, and punch in the log of 5/8 at the end there, and they should be the same value. But yeah, so just again, first I'll use the power rule. So far I haven't had to do that. We'll do that in the next example. And then going left to right, taking 2 terms at a time, I'm applying the quotient rule or product rule, as needed. Right? If there's a difference, quotient rule. If there's a sum, product rule. Right, so in the next example, I do have a scenario where we're going to start off using that power rule. Right. So you see I have a half in front of this log, so I'm going to use the power rule with the half. And then I have a 3. You can ignore the negatives with the power rule because you'll take care of the negatives later when you use the quotient rule. So this 3 in front of this log, I'm going to also apply the power rule here. So we have the log base 2 of x squared plus, and then this half goes inside. We have the log base 2 of, this x minus 1 in there to the half power. And you can leave it this way if you wish. You can also write this as the square root of x minus 1. Remember, to the half power means square root as well. Then the minus I'm keeping, and then putting that 3 inside, and we have the log base 2 of x plus 3 squared cubed, right? Whatever was inside here to the third power. So we'll make that to the sixth power, power to a power rule. Then the first two, now that I've applied the power rule, now I can go through left to right, just take two terms at a time. I'm going to be applying the product rule for the first two terms because it's a sum of two logs. So this is the log base 2 of x squared times, and then I'm going to write this as the square root of x minus 1. Alright, that's the same thing as x minus 1 to the 1/2. So there's those first two terms written as a single log with a product. Then we have minus the log base 2 of this x plus 3 to the 6th. Alright, because squared, cubed, that's to the 6th power. Multiply those. And then finally, there's only two terms left, and they're being subtracted, so I'm using that quotient property to put these together. So this is a single log base 2 of, and then the first input is the numerator, x squared times the square root of x minus 1. And the second input just goes in the denominator, right? X plus 3 to the 6th, all in the denominator there. And there we go. All right, we have applied all the rules and gotten it down to be a single logarithm. And then, as I've done in previous videos, you can punch this expression into the Desmos calculator and this expression, and you'll see that they're going to be equivalent, have the same graph, have the same outputs for certain values of x. Not every value of x, but for values of x that they share, that they have in common in their domains. But I'll leave that to you. But we're getting down to a single logarithm, so I'm done. Alright, same thing for the next example. Doing the same steps. All right, power rule first if I need to, and then go left to right, two at a time. Use the quotient rule and product rule as needed. So in this one, I'm seeing the 0.5 or the 1/2 in front of this log. So I'm going to apply the power rule there with the half. And then I'm seeing this 3 in front of this log times this log. And it's only times, right? If it was 3 plus, you're not doing it. All right, it's only when you have a coefficient, a number times a log, that you can apply that power rule. And those are the only ones that I can apply the power rule to. So now I have the log of 5 plus, and then the log of the square root of x. All right, remember that's x to the half, but you can write that as the square root of x if you wish. Minus the log of this 7x minus 1, and then putting the 3 in as a power, right, plus the log of the quantity x minus 1 cubed, right, for the input of that last log after applying the power rule. Alright, then I take two at a time. Here I have a product, right, because there's a sum, so this would be the log of 5 times the square root of x, or 5 times x to the half, 5 times x to the 0.5 power. Then the rest of it, right, minus the log of 7x minus 1, plus the log of x minus 1 cubed. Alright, then these two, I'm using the quotient rule because there's a difference. So this is the log of, 5 times the square root of x, divided by 7x minus 1. And then I still have this plus the log of x minus 1 cubed. And then finally, product, which will just put the x minus 1 cubed in the numerator. If you have addition, the second one goes in the numerator. If you have subtraction, the second input goes in the denominator. It's that simple. So we end up with a single logarithm. This is equal to the log of 5 times the square root of x times the quantity x minus 1 cubed, all in the numerator, and then 7x minus 1 in the denominator. And that's it. That's the original expression completely condensed, right, written as a single logarithm. And once again, you can go to a calculator, plug in different values of x as long as they're valid. Right, remember, you can't have a negative number inside a logarithm. So as long as you're plugging in valid numbers for x, the expression in the beginning should have the same value as the expression at the end here. But I'll leave it to you to check that. Example 5, just got a few more of these. Same thing. All right, same thing. Now, I know I said a number, but really any expression that's multiplied by a log, you can use the power rule for. I can apply the power rule to this 4 here and times this log. I can apply the power rule to the 2 times this log, and I can apply the power rule to this 1 over x times this log. Now, it doesn't have to be just a number, because remember, any expression represents a number. You just don't know what that number is, that's all. So after applying the power rule, this becomes the log of x to the second power minus the log of the quantity x plus 5 to the fourth power, and then plus the log of the quantity 3x plus 5 to the 1 over x power. Or you could write the xth root if you want to use roots. Alright, and then going two at a time, these two I'm going to do a fraction quotient rule. Right, this will be the log of x squared divided by x plus 5 to the fourth. And then you got this still, this plus this log of 3x plus 5 to the 1 over x power. And then when you add, you're using the product rule. All right, so this 3x plus 5 to the 1 over x power is just going to go in the numerator of this fraction here. This will be a single log of the product of these, which would be x squared times 3x plus 5 to the 1 over x power in the numerator, and then the denominator is x plus 5 to the fourth power. And that's it. Same steps every time, right? I'm applying the power rule first for any expression times a log can go inside that log as a power. And then I go left to right, again, just two terms at a time, using the quotient rule or product rule as needed, down to a single log, condensed. Okay, this next expression, now if you want, I could distribute the 4 first, or I could wait till the end and then put the 4 in as a power. So it really doesn't matter. So if I was to distribute the 4, again, it doesn't matter. I'll distribute the 4 first. So if I distribute the 4, that's going to give me 12 times the log of x plus 4 times the log of x plus 5, then minus 4 times the log of 2x plus 3. And then I can put the 12 and the 4 and this 4 in as powers, right, applying the power rule. So this is the log of x to the 12th power plus the log of x plus 5, all that to the 4th power, minus the log of the quantity 2x plus 3, also to the 4th power. Alright, and then if you were to do this two at a time, these would go in the numerator, they're getting added, they're getting multiplied together, those go in the numerator, and then the minus will put this 2x plus 3 to the 4th in the denominator. So I'll just skip a couple steps here. This will end up being the log of, the numerator will have x to the 12th times x plus 5 to the 4th, and the denominator will have this 2x plus 3 to the fourth. All right. Again, you can do two at a time, but if you see it after a bit of practice, you should hopefully be able to see what's going to go in the numerator and denominator of your final input. And there you go. We have a single log, a condensed expression. All right. So example 8, real simple. This is just going to be the log of 2x to the fourth times 3x to the fifth, and of course you should be simplifying things. 2x to the fourth times 3x to the fifth would be 6x to the ninth. So this is equivalent to the log of 6x to the ninth. And there we go. I mean, that was a simple one because there was just a sum of two logs. No power rule to use, no quotient rule to use. All right, in example 8, first I'm using the power rules. I'm putting the 2 inside and the 3 inside. So this is going to be the log of x squared plus the log of the quantity x plus 1 cubed. And now I just have a simple sum which becomes a product, right? The log of a product. So the log of x squared times the quantity x plus 1 cubed. And there we go. That's a single log. The thing is condensed. And again, you can double check on your own, with specific values of x to see if those are actually equivalent. All right, then my final example, more of the same. More of the same. All right. Now, if you don't like the whole log base 7 of a divided by 3, you can rewrite that. This is 4 times the log base 7 of c plus, and remember, dividing by 3 is the same thing as multiplying by a third. This is a third times the log base 7 of a plus, and the same thing here, 1/3 times the log base 7 of b. And then I can use the power rule with the 4 and the third here. This is the log base 7 of c to the fourth power plus the log base 7 of a to the 1/3 power, which you could also write as the cube root of a plus the log base 7 of b to the 1/3 power as well, which again you could also write this as the cube root of b. And this is all one big sum, right? You'd be multiplying these and then you'd be multiplying by this, right? It's all one big sum. This is just going to be a log of a product. A log base 7 of a to the 1/3 times b to the 1/3 times c to the fourth. I just put them in alphabetical order, that's all. And this is great. Now if you wanted to write cube roots, this is the cube root of a times the cube root of b, you could put those together. Say this is the log base 7 of c to the fourth times and then the cube root of ab. Right. That's also valid. Right, cube root of a times cube root of b would be the cube root of ab. Same thing. Right. And once again, you could take the expression in the beginning, punch in the expression at the end, change the values of a, b, and c to be whatever positive numbers you want. And the expression in the beginning and end should have the same value no matter what you do. All right. So again, it was a lot of the same. Right, I used the power rule to put expressions or numbers times a log inside as a power. Then I went from left to right, 2 terms at a time most times, and used the product rule if there was a sum of logs, used the quotient rule if there was a difference of logs, and then got it down to eventually being a single logarithm like this here. Great, and that's all I got for you today. Hopefully watching me go through these 9 examples here helps you in some way when you're asked to condense a logarithmic expression on your own. And thank you very much for watching.